Time travel. The very phrase sparks our curiosity and ignites our imaginations. For centuries, humans have been captivated by the idea of journeying through time. Imagine witnessing historical events firsthand or glimpsing the future. What wonders might we uncover? What mysteries could we solve? From ancient myths to modern science fiction, time travel has been a recurring theme in storytelling. We've all heard tales of time machines and adventurers who dared to tamper with the fabric of time. Think of H.G. Wells' The Time Machine or the iconic DeLorean speeding through time in Back to the Future. These stories capture our fascination with the unknown and the allure of altering our destiny. But is time travel merely a figment of our imagination, or could it be within the realm of possibility? As we delve deeper into the mysteries of the universe, we discover that the laws of physics might allow for time travel, albeit in ways we are only beginning to comprehend. The quest to understand time travel leads us on an exhilarating adventure through the cosmos, challenging our perceptions of reality and pushing the boundaries of human knowledge. Our journey into the realm of time travel begins with a revolutionary thinker, Albert Einstein. His groundbreaking theory of relativity, published in the early 20th century, shattered our conventional understanding of time and space. Einstein revealed that time is not absolute as we once believed, but rather relative. Imagine time as a flowing river. We often perceive it as constant and unchanging. However, Einstein showed us that time is more like a river with varying currents. It can speed up or slow down depending on factors like speed and gravity. This mind-bending concept is crucial to understanding the possibilities of time travel. Einstein's theory suggests that time is intertwined with space, forming a four-dimensional fabric called space-time. Massive objects like stars and planets create curves in this fabric, much like a bowling ball placed on a trampoline. These curves are what we experience as gravity. This understanding of space-time opened up new avenues for exploring the nature of time and the potential for time travel. If we could manipulate gravity or travel at incredible speeds, could we also manipulate time itself? The answer, as we'll see, lies in the strange and wondrous phenomena predicted by Einstein's theories. One of the most intriguing consequences of Einstein's theory of relativity is the phenomenon known as time dilation. This concept fundamentally alters our understanding of time and space. Time dilation occurs when time passes at different rates for observers who are either moving relative to each other or are in different gravitational fields. This means that time is not a constant, but rather a variable that can change depending on speed and gravity. Imagine two identical clocks, one remaining on Earth and the other traveling at incredibly high speeds through space. These clocks, though identical, would measure time differently due to their relative motion. According to the principles of relativity, time would slow down for the clock in motion relative to the stationary clock on Earth. This effect becomes more noticeable as the speed of the moving clock increases. This difference in the passage of time, known as time dilation, becomes significantly more pronounced as the speed of the moving clock approaches the speed of light. At such high velocities, time can slow down to a crawl. Let's picture a spacecraft embarking on a journey to a distant star system at a significant fraction of the speed of light. The implications of such a journey are profound. For the astronauts on board, time would seem to pass normally. They would live their lives, work, and age just as they would on Earth, unaware of the time dilation effects. However, upon their return to Earth, they would find that far more time had elapsed on Earth than they had experienced during their journey. This discrepancy could be years, decades, or even centuries, depending on their speed and duration of travel. While we haven't yet achieved such incredible speeds with human travel, time dilation has been experimentally verified using highly precise atomic clocks. These experiments have provided concrete evidence of time dilation. These precise timekeepers have shown that time does indeed slow down, even at the relatively low speeds we experience in our daily lives, though the effect is minuscule. This has profound implications for our understanding of time. Time dilation provides a tantalizing glimpse into the malleable nature of time. It challenges our conventional notions and opens up new possibilities for the future. It suggests that time travel into the future is not merely a fantasy, but a real possibility. By understanding and harnessing time dilation, we could potentially unlock the secrets of time travel. By harnessing the power of time dilation, we might one day be able to journey thousands or even millions of years into the future. The possibilities are as vast as the universe itself. Section 4. Wormholes, shortcuts through space and time. While time dilation offers a potential path for traveling into the future, what about journeying to the past? The idea of moving backward in time has fascinated scientists and dreamers alike for centuries. This is where the concept of wormholes comes into play. These mysterious structures could theoretically allow for such incredible journeys. Wormholes are theoretical tunnels that connect two distant points in space-time. They are often visualized as shortcuts through the fabric of the universe. Imagine folding a piece of paper in half and poking a hole through it. This simple analogy helps us understand the complex idea of a wormhole. This hole, representing a wormhole, creates a shortcut between the two sides of the paper. In the same way, a wormhole could connect two distant points in the universe. In the vast expanse of space, wormholes could potentially connect two different points in time as well. This means they could serve as portals not just through space but through time itself. By traversing a wormhole, one could theoretically travel from one point in space-time to another, potentially arriving at a point in the past or future. This concept opens up a realm of possibilities for time travel. However, the existence of wormholes remains purely theoretical. Despite being a fascinating idea, we have no empirical evidence to prove they exist. They arise from complex mathematical equations in Einstein's theory of general relativity, but we have yet to observe them directly. These equations suggest that wormholes could exist, but they also highlight the challenges in proving their existence. Even if wormholes do exist, their stability and traversability remain uncertain. Theoretical models suggest that they might be highly unstable. Some physicists believe that wormholes might be incredibly unstable, collapsing before anything could travel through them. This instability poses a significant barrier to their practical use. Others speculate that immense amounts of energy, perhaps even more than the total energy output of our sun, would be required to keep a wormhole open long enough for a spacecraft to pass through. This energy requirement makes the practical use of wormholes even more challenging. Despite these challenges, the concept of wormholes continues to captivate our imaginations, offering the tantalizing possibility of shortcuts through space-time and journeys to the past. The idea that we might one day traverse these cosmic tunnels keeps the dream of time travel alive. Section 5. Paradoxes of time travel, tangled timelines. The prospect of traveling through time raises a host of mind-boggling paradoxes that challenge our understanding of cause and effect. Time travel, a concept that has fascinated humanity for centuries, brings with it questions that stretch the limits of our imagination and logic. One of the most famous is the grandfather paradox. This paradox is often used to illustrate the potential problems and contradictions that could arise from time travel. Imagine a scenario where a time traveler ventures into the past and, for whatever reason, prevents their own grandfather from meeting their grandmother. This action, seemingly small, could have enormous consequences. If the grandfather never meets the grandmother, the time traveler's parent would never be born, and consequently, neither would the time traveler. This creates a loop of impossibility that defies our understanding of reality. But if the time traveler was never born, how could they have gone back in time to prevent their own existence in the first place? This question leads us to ponder the very nature of existence and causality. This paradox highlights the potential for logical inconsistencies and contradictions that arise when we tamper with the past. It forces us to consider the delicate balance of events that lead to the present moment. It suggests that changing the past, even in a seemingly insignificant way, could have ripple effects that unravel the very fabric of our existence. The butterfly effect, a concept where small changes can lead to significant consequences, is often cited in this context. Physicists have proposed various solutions to resolve these paradoxes. Some theories suggest that the universe has built-in mechanisms to prevent such paradoxes from occurring. Some suggest that time travel to the past might be impossible, preserving the integrity of causality. This would mean that the timeline is fixed and unchangeable, no matter what actions are taken. Others propose the existence of parallel universes, where each possible outcome of a time traveler's actions plays out in a separate timeline. This theory allows for multiple realities to coexist without causing contradictions. The paradoxes of time travel remain a subject of intense debate and speculation, reminding us that the universe is a far stranger and more complex place than we can currently comprehend. As we continue to explore these ideas, we may one day unlock the secrets of time itself.